Right, here I want to explain the homework for M1, exercise 1C, and the questions are 16, 18, and 19. So please study carefully and follow through the steps. Now in question 16, you want to find a constant term in the expansion of this product. So what you need to do, you do have to expand them, but not all the terms, because all you want is the constant term. So look for where the x term will actually cancel each other out, because 1 of the x is actually a reciprocal function. It's 1 over x squared. So let's see. First expand just the x plus 2 to the power of 6. So we apply our binomial theorem. Now I want to expand up to the 4, and the other terms I'm going to skip it, because I note that on the other term I got 1 over x squared and all square, so the most I'm going to have is power to the 4. Now expand 1 over x squared minus 1 square. Now note that the sign on the second term changes to minus, and the reason for that is because I have minus 1 to the power of 1 in the second term. So be careful here not to make mistake. So therefore the product of these two terms, and by comparing the constant term alone, so the constant term, the first one is 2 to the power of 6 times 1, and the second is actually 15 times 2 to the power of 4 x squared. And I'm looking for x squared because on the second term I have 1 over x squared, and that will cancel each other out. So as you can see. And the next term I'm looking for is x to the power of 4 rather than x to the 3, because this will cancel nicely with the 1 over x to the 4. And the other terms are just dot dot dot. Now, if you look at this, all these 3 terms add together will become a constant, and there are no x involved. Okay, so think about it carefully. So try and finish off yourself. Now in question 18 is different from question 16. Here we're asked to expand this binomial expression in ascending power of x, and we're told that the fifth term is the constant term. So there's 2 information here. First, the fifth term means that's when r is equal to 4. And then we have to put that in the sequence of ascending power of x. So let's do that and think about it carefully. Now you could expand this, or you could use a general term approach. So general term for this now note here, I want to express this in ascending power. So by looking at this, I got 1 over x squared, and by ascending the smallest term, then I would have the power to the n from the start. So I will have n minus r for my first term, because for n r starting from 0, and the other term I will put it into r, and that way I will have ascending power of x. So now let's consider what does it mean by the fifth term and a constant term. Now, if you follow through with the algebra, you can see that x to the power of 7r minus 2n. Now, we're told that the fifth term is a constant, which is x to 0. And the fifth term, that is when r equal to 4. So you're going to use this information and put it into our general term, especially for the x to the power 0. So we put r equal to 4 to the power in the power of x, and that power should be equal to 0 because I will end up with a constant term. So here, I find n is 14. So I hope this is going to help you to do B. So please try and finish off B. Now this question 19 is very typical of DSE type of questions. It's a little bit challenging, but the concepts stay the same. So look at this. On the left hand side we have a binomial expression and we don't know the n. But on the right hand side we know part of the expansion. And some of the terms actually expressed as an A and B. So what we have to do is to consider both left hand side and the right hand side, and if I expand on the left hand side followed by comparing the coefficients on the right hand side, this might help me to formulate some equation to find the unknowns of n, a and b. So what I have here, the coefficients on the right, the constant term x is 0, a is x to 1, and b is x squared. So I'm going to expand the left hand side and then compare the coefficients on both left and right. So first the expansion on the left. Again, apply the binomial theorem. Now be very careful with the algebra here because we're x over 10. Now again, as you can see, I only expand up to the x squared because on the right hand side it only involved up to the maximum x squared. And note that the dot dot dot, and this is important notation. That's to tell that the sequence does continue except that we're not writing it. So it's important to have the plus dot 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 at the end. Now I'm going to compare coefficients of the x0 for the left and the right, x to 1 and x to 2. Now as you can see, by forming these three equations, you could now think of a way of finding first the value of n. Knowing the value of n, you would be able to find the value of a and b. So please try. You must not fail. Well, thank you very much for listening. Hope you have learned something by doing these three questions. See you in class.